Hi guys, good evening. I am Ilangovan, onlineaxi.com personal for zoology. So last class we started something about the AIDS virus, the HIV virus responsible for causing the disease AIDS. We had seen something about the structural aspects of the AIDS virus. Then now let's pass on to the next part, how far the virus is responsible for causing the disease. That is pathogenesis. The word pathogenesis refers to the ability of any pathogenic organism to cause disease. The ability to cause disease. And here under this category, how does the HIV virus normally cause the disease? So it targets cells or two types. That means it is attacking two different types of cells. One, macrophages, another one, T lymphocytes or helper T cells, one type of cell CD4, cluster differentiation molecules, T helper cells, one type CD4. So these are all the two cells normally affected. But the place of actually the multiplication more and more occurs in the reservoir cells, namely the macrophages, one type of WBC. A type of WBC called monocyte. Once it is infected by any pathogen, it gets converted into macrophage, a large cell capable of swallowing or engulfing the microorganisms or pathogens. So as a general rule, you know that when the retrovirus contains actually the two identical strands of the two identical strands of RNA. Now they are being converted into what is called DNA by one enzyme, the reverse transcriptase, a peculiar character. That is why normally these are all called retroviruses, as they have the ability of doing the process of reverse transcription. So more and more virus particles are produced by this macrophage. Hence this macrophage is called as HIV factory, because more and more HIV viruses are being produced. So I talked about this one in the last class itself. Now the second type of cell which is being normally attacked by the virus, helper T lymphocytes, that is TH. So within these cells also the parasite multiplies, the virus multiplies just like in the macrophages. So producing many progeny viruses. Progeny, the word refers to the young viruses, or simply we can say the daughter viruses. And when these viruses are increasing in number in these cells, what will happen? They cause the lysis. That is nothing but the destruction of the cells T lymphocytes. Now the T lymphocytes are taking part in the production of antibody. They are responsible for stimulating the B lymphocytes to produce antibodies. So that is why normally the viruses are very clever, attacking mainly just the T lymphocytes, which are the inducers of these B lymphocytes to produce antibodies. It is a main switch. We can say that is a manager of the factory, stimulating the workers like B lymphocytes to produce the antibodies. So once actually the lymphocytes are attacked by the virus and multiplies within the T lymphocytes, more virus particles are produced by means of the same mechanism what we have in the case of macrophages. So once the number of virus particles have been increased inside, that is lymphocytes, the lymphocytes are destroyed, damaged, or lysed, so that we can get actually more and more cells get liberated into the plasma. By the time what will happen, the depletion of the lymphocytes occur because they are being destroyed. Now the released virus particles attack the fresh cells by entering into the, once again they are repeating the cycle. So this is what is happening. So one of the abilities of the virus particles, they can actually have the ability of just replicating their RNA, they are converting their RNA into DNA, and they are getting incorporated into what is called the host cell and multiplying along with the host cells, so that the DNA which is integrated with the host cell also can direct the synthesis of what is called the RNA of the virus, and also the virus particles being packaged because of the formation of capsid. All these things happening within these two cells, namely the helper T cells and also that is the macrophages. So we are getting more and more number of viruses. Now here shows a simple picture. So now this is the virus particle containing the viral RNA. See that I represented only one, but we have two identical strands of RNA. Now this RNA gets converted into what is called viral DNA, having a double stranded structure. So normally the DNA is directing the synthesis of RNA. But in the case of this virus, the enzyme reverse transcriptase causes the synthesis of viral DNA from RNA. Here the RNA directs the synthesis of DNA. In many cases, in the normal instance, the DNA only directs the synthesis of RNA, but in this case, the viral RNA directs the synthesis of viral DNA. Now this viral DNA gets incorporated in the or with the, that is the host DNA, that is a cell DNA, what we call this one the T lymphocytes as well as the macrophages, and then now it directs the synthesis of its own RNA. Now like this. So these viral RNA actually they are being packaged by the production of the capsid to form a new virus, and this viral RNA may be once again reverse normally transcription process with the help of reverse transcriptase may produce the DNA. So in this manner thousands of virus particles being produced because of the repeated activity of this reverse transcriptase to form many DNA molecules which direct the synthesis of new RNA of the virus. Now the viral RNA are being packaged within the capsid because of the production of this capsid coat, and ultimately we have formed a new virus in many numbers which cause the lysis of the cells leading to the death of lymphocytes. Ultimately the number has been depleted, the number has been decreased. This is what is happening during the pathogenesis. So the virus not only attacks the macrophages, that is what is called the lymphocytes, but also they attack a variety of cells. Even they can form, you see that one, the synovial fluid of the joint cavity, the cerebrospinal fluid. So almost all the cells are being actually attacked by this virus in due course of time. Now the next one, so the first one we talked about the nature of the virus particle structure, and then just we have seen about how far the disease being developed because of the infection of the virus. Now how does transmission of the HIV take place? So normally this HIV virus or the AIDS virus not spread by means of mere physical contact or mere touch. It will not be spread by means of mere touch or by means of physical contact. We have already seen it is actually not a congenital disease because it is being acquired during the lifetime. The major means of transmission is only through what is called the sexual contact. So it is being spread only through body fluids. Even it cannot be spread through what is called the air medium in the form of what is called the spread of the particles, the virus particles. So it can be transmitted only through a fluid medium, particularly the body fluid medium. Even it cannot be transmitted through ordinary liquid medium of water. It can be transmitted only the fluid medium of the body, the organism. So it is not spread by mere touch or mere physical contact. It is being spread only through the fluid medium of the body. Now what are the different means of transmission? The main means of transmission of this virus is sexual contact. This is why I mentioned initially that it's transmissible, sexually transmitted disease, not a contagious disease, not actually a congenital disease. It is being transmitted only through sexual contact or by sharing or by means of fluid transmission, namely the body fluid blood, through transmission of infected blood to a normal person. And also during organ transplantation or tissue transplantation between two individuals of infected and normal individual. Then fourthly, when a person is sharing the syringes, particularly it is very common in the case of drug abuses. The drug abused person normally using the common syringe for just injecting the drug for their hallucination or making them just actually, that is, feeling somewhat good. So they are addicted to what is called the drug. So these persons use a common syringe for just injecting that actually the drug. In such cases also it is being spread because it is a body fluid transmission. And finally, it is also being transmitted somehow congenitally, we can say, from mother to fetus. So the infected mother transmits the disease to her child through the placenta while the child is developing inside the womb of the mother. This is also possible if the mother is infected. But the main means of transmission is sexual contact, and that is what is called blood transmission, and others are possibility if you have transmission by means of actually donation of organ, or that is the transplantation method, or using or sharing the razors or the blades by the people or the syringes even. just in the case of drug abuses, or from mother to fetus if mother is infected. So these are all the different means of transmission. Now what are the symptoms? So almost all the symptoms are the effects of some other diseases, and those diseases which enter into the body because of an infection. The first symptom normally it is called acquired immunodeficiency symptom because the immune system is affected. There is a depression of the immune system, so it causes profound immunodepression. The meaning for that one, the immune system is unable to resist against other diseases because of the infection with the virus. So what is the reason for that one? It is due to the depletion or decrease in number of one type of cells, what is called T lymphocytes called CD4. One type of helper TH, we can say helper T lymphocytes or TH cells. And under this category we have one type of cell CD4, cluster differentiation molecule. CD4 cells able to differentiate what is called cluster of just active molecules. So cluster differentiation molecule cells, and that is why these are all the cells normally responsible for stimulating other type of cells, namely the B lymphocytes, to produce antibodies. Once these cells are affected, there is no stimulation for the B lymphocytes to produce the antibodies working against AIDS virus. That is why the immune system being suppressed or depressed, it is unable to resist against any disease. Number 2, significant weight loss. So a person who is infected with this virus, once getting the disease, he is losing the body weight, at least 10% of the body weight being lost all of a sudden. Suppose a person having 50 kilograms of weight, he is losing nearly 5 kilograms of weight within a short period of time. A sudden loss of body weight. 10%, generally 10% of total weight. Then chronic diarrhea, now one which is lasting forever. Chronic, we have two types of disease if you see, chronic disease and acute disease. So chronic diarrhea, the one which is lasting for a long time, for more than 1 month, then it is called chronic. Normally the diarrhea lasts only for 2 or 3 days, and then afterwards it is being suppressed. But in this case it is lasting forever, nearly for more than 1 month. That is why it is called chronic diarrhea. Then night sweats. The night sweat is one of the symptoms of tuberculosis. Persons affected with the tuberculosis bacterium have this symptom. So this symptom is because of the effect of the tuberculosis bacterium, the one responsible for causing the tuberculosis, because persons infected with this virus can easily acquire the tuberculosis bacterium, the disease. Also, persistent cough, a dry cough, lasting for more than 1 month, that is why it's called persistent. Not because of cold, not because of the release of what is called phlegm, but it is because of actually the infection. Dry cough, persisting for a long time, for more than 1 month. Then prolonged fever, it's also for more than 1 month. So if any fever, any dry cough persisting in an individual for more than 1 month, it is one of the symptoms of the disease AIDS. Then opportunistic infections. Some pathogens are waiting for a chance to enter into the body. One such a pathogen is nothing but the tuberculosis bacterium. That is maybe the Mycobacterium tuberculosis. It is waiting for a chance to enter into the body once our immune system is normally lapsing. So because of the AIDS virus infection, as we are losing the immune power, now immediately the tuberculosis bacterium enters into the body, causing actually the disease. And that is why it's called opportunistic disease, waiting for the chance to enter into the body and causing the disease, the organism, the pathogen, the tuberculosis bacterium. So tuberculosis is an example for opportunistic disease. Another disorder, candidiasis. This is nothing but fungal infection, particularly in the mouth region. First, on the surface of what is called the mouth, some black patches, pinkish patches in the mouth cavity, candidiasis, affecting the throat, also a fungal infection. So this is also an opportunistic infection. Once you have the immune depression in your body, not having any resistant power, you are immediately attacked with a fungal infection. That is why these are examples for opportunistic infections because of the HIV infection. Then a kind of viral infection, recurrent herpes zoster. So recurrent herpes zoster, the herpes varicella virus we have, zoster virus. Normally the varicella virus causes chicken pox. We have the blisters all over the body. That is a symptom of chicken pox. But in the case of herpes zoster, a kind of viral infection, we have patches of blisters just all around the mouth, in the neck region and also in the chest region. That is a viral infection coming and going, and just we are being relieved once we are getting the infection. That is called recurrent infection, occurring just continuously. It stops today, coming once again tomorrow, like that. That is called recurrent herpes zoster infection. The loss of memory and intelligence, as the virus is moving towards the brain, getting settled down in the cerebrospinal fluid, a kind of fluid normally occurring in what is called the cavity of the brain and also in the cavity of the spinal cord. So these cavities are named accordingly, that is ventricles of the brain and the spinal canal of the brain. So the spinal canal of the spinal cord, not brain, the spinal canal of the spinal cord. So these cavities are filled with a fluid called CSF, cerebrospinal fluid. These fluids also contain cells, so that is why the virus gets settled down in these cells, affecting the cells, causing damage to the brain cells. So you are losing the memory and also the intelligence. Then you know that when a cancer is nothing but that when rapid abnormal and controlled multiplication of cells. If any type of cell division that occurs in an uncontrolled manner abnormally, then we can say that is called a cancer. So normally cancer has its own symptoms. So one type of cancer occurs in a body is called Kaposi's sarcoma. This sarcoma means cancer in the connective tissues. Muscle is a connective tissue, bone is a connective tissue, like that. So any connective tissue is normally affected by cancer, that is called sarcoma. One type of sarcoma proposed by Kaposi sarcoma. In a normal person, the symptom of Kaposi sarcoma is different. It affects mainly the extremities. But in the case of AIDS persons, it produces many purpley scattered lesions all over the chest region. Scattered purpley lesions all over the chest. So it also normally occurs in normal persons, normal individuals, those persons who are not being affected by the AIDS virus. But the people who are affected with this AIDS, then they have cancer, Kaposi sarcoma, but the symptoms are different. Here they have purpley scattered lesions all over the chest and also in the throat region. This is what we have the main symptom for AIDS affected person and the symptom for normally affected persons. So these are some of the symptoms related to. Then the next question arises, how can we prevent this disease, and for that you have to go through the diagnosis of the disease, whether the person is positive to AIDS virus or not. So for that we have to diagnose a person, the suspected person. For diagnosis, there are two actually different types of tests. The two tests are based on detecting what is called anti-HIV antibodies. So we are doing what is called the biochemical test. The biochemical test is based on the proteins. We have two different types of proteins. We have P17 protein on the surface envelope and then P24 protein just actually in the capsule. So it is not easy to just observe this one in a normal microscope. We need electron microscope, that too in a fluid medium. So that is why it is always easy to find the presence of the virus or whether the person is positive or negative to AIDS by means of biochemical analysis. How it can be done? So the biochemical analysis is based on some color test. Now actually for that what they are actually identifying, they are detecting or finding out whether the person, the suspected person, has anti-HIV antibodies. You know that once any virus or any pathogen enters into the body, it stimulates the production of antibodies to kill or to eliminate that pathogen or antigen. And likewise here, once a virus enters in the body, the immune system develops some antibodies to fight against the HIV virus. Suppose you want to find out the presence of AIDS virus, you can find out whether the person has HIV antibodies in his body or in her body. If HIV antibodies are found, then we can say the person is said to be, that is what is called HIV positive. So instead of just observing the cell cytological study, we are doing the biochemical analysis by means of finding out the anti-HIV antibodies. So we are taking a sample of that person. So if the person has anti-HIV antibodies, suppose we are adding the normal protein present in that virus, an example P70. So if antibodies are there, they will react with this P70 or P24 just proteins what we are adding to the medium just to find out whether that blood serum what we collected the sample contains antibodies or not. If antibodies are present, they will react with these proteins, either the protein coat or with the capsid coat. So we are getting some colored reactions by which one can say the person is RH positive, I made a mistake, anti against or HIV positive or negative. So these are all the following two tests what we are going to just see about the diagnosis of AIDS. One such test, a preliminary test, not a confirmative test, a screening test, and that test is based on sensitivity, and that is what is called ELISA test. Expansion for that one, enzyme linked immunosorbent assay test. I mentioned already it is a sensitive test. It is a preliminary test, first test, but it is not a confirmative test. So we are screening the blood whether the person has HIV antibodies or not. So the same type of antibodies also produced by some other viruses. So we can find it so whether the person has antibodies against the virus. I mentioned already there are two types of antibodies produced by the virus because they have two different types of proteins. One P17 protein, another one P24. So when you have this P17 protein added to, so the P17 protein is present not only in the case of AIDS virus but also other viruses. So we have to find out whether that protein is found or not. If the protein is found, definitely it will react with the antibody. So we are getting the result. But it is not a confirmative test because we have that antibody produced by the virus is also produced by some other viruses. So specific viruses produce the same type of antibody. So we have to actually localize. We are just actually assort what group of viruses now they produce such antibodies. Now we have found these are all viruses under the list. They produce antibodies similar to the AIDS virus. So we can conclude that person may or may not have, that is AIDS virus in his body or in her body. That's why it's called what is known as a preliminary test, not a confirmative test. So it is used on detecting HIV antibodies. Simply one protein, based on one protein, and that protein normally produces antibody if the virus contains that protein. So this is one test. Simply we can say a preliminary test to find so whether the person is having AIDS virus or not. But for confirming that one, we have another test, what is called Western blot test, blotting, isolation, separation, etc. So this test is a confirmatory test, and this test is highly specific because the reaction in this test is shown only by the AIDS virus. It is not shown by any other virus. So if you are taking the virus, I mentioned already we have the protein envelope. This is the capsid coat, the capsid. The capsid contains inside, you know that one, two single-stranded RNAs, and now this capsid protein is present only in the AIDS virus. That protein stimulates the production of antibodies in the suspected person's blood. So these antibodies are produced only by that protein. That protein is found only in AIDS virus. Now when these antibodies are mixed with the protein normally found in AIDS virus, then the reaction produces a specific color. That is a confirmative test. That's why I use the term here. You see that one. It is highly specific and based on specific antibodies to viral core protein. So this code is also found out actually protein. The first reaction is based on the reaction between the antibodies and this protein. The second test is based on the proteins found in the capsid coat and the antibodies produced, so that we can confirm that person is HIV positive. So anyway, it is based on detecting HIV antibodies to viral core proteins. The second test that is found only, that viral core protein is found only in retroviruses like AIDS virus. Now, so far we have seen actually the structure of the virus, and also that is the pathogenesis, and also the different tests. Then how can we prevent the spreading of disease? So you know that one, prevention is always better than cure. So after getting the disease, we are managing the disease. That is called disease management. Once you got the disease, then it can be controlled. In some cases it can be cured, in some cases it cannot be cured. That aspect is called disease management. After getting the disease, we are just taking some measures to just prevent further spreading or to prevent actually the disease. That is called management. But this one is prevention. Before getting the disease, we have to have certain what is called specific measures to prevent the development of the disease or to prevent the spread of the disease. Number one, as the disease being spread mainly through sexual contact, now the person should have protected sexual behavior, wearing the condoms by the male or wearing the cervical cap or any other preventive, just what is called contraceptive methods. And for example, the condoms, the cervical cap, these are all contraceptive methods. They prevent not only what is called the fertilization process to get pregnancy, but also used to prevent the entry of the AIDS virus. So that is called protective sexual behavior. The second one before, this is the first aspect because it is being spread mainly through sexual contact. And secondly, screening the blood. So you have to analyze the blood, whether the person is HIV positive or not. And that is called screening the blood before it is being donated, before it is being transfused. That is second one. And also we have to make the awareness of the disease through different agencies. That is what is called participation of agencies. The school teachers, then NGOs, then voluntary organization in AIDS awareness program. That is very important. So nowadays we are having so many such programs to make the people aware of the effect of the disease. Then again, just actually education. Again, once again, education to the public, particularly the adult, the people at the adolescent stage. What are the things being done or not to be done? So we have to give education to the people about the do's and don'ts in contraction of AIDS. So we have to avoid certain things so that we cannot contract that AIDS virus. And again in the salon, you know that one, we have to just have a separate razors or blades for shaving. In such cases, we have to avoid what is called the common razors and blades in the salon. And finally, for such people who have already developed the disease, we have to manage the disease by providing antiretroviral drugs. So we are having specific antiretroviral drugs which are not used to cure the disease, but they can arrest the further spread of the disease. They can prevent the spread of the disease further. And some of the drugs actually, as mentioned by World Health Organization, represented by World Health Organization, or azithromycin, simply called as AZT, azithromycin. Then we have sildenafil or cyclovir. So many antiretroviral drugs are available that should be given to the people who are affected by the government, either freely or with low cost. So making the retroviral drugs, antiretroviral drugs available for the people who are already affected. So prevention as well as control and management. So once you got the disease, we have to manage the disease either to arrest the spread of the disease or to just actually prevent the disease. So these are all the different measures used to manage the disease and also to prevent the spread of the disease. So far we studied under the human health and welfare the different kinds of diseases caused by protozoan, bacteria, fungal, helminthic, and also specific information about the AIDS virus because it's one of the pandemic disease, we can say pandemic, a worldwide disease causing death or taking away the lives of people, many people all over the world. That's why we are giving more importance to such diseases. Nowadays, the World Health Organization also stressing the importance of preventing the spread of the disease throughout the world. So we are giving a few words about this one, not much. At your level, we are given only a few things about the AIDS virus and their causes, effects, etc.